Hi everybody, in this recording we'll be going over section 3.2, Rolle's theorem and the mean value theorem. Our goal is that by the end of this presentation you'll be able to use and understand Rolle's theorem and the mean value theorem. In section 3.1 you learned about the extreme value theorem, which states that both the minimum and the maximum of a continuous function exist in a closed interval a/b. Both values can occur on the endpoints. Now we will introduce theorem 3.3, Rolle's theorem. So we let f be a continuous function on the closed interval ab and differentiable on the open interval ab. If f of a is equal to f of b, then there is at least one number c in the open interval ab such that f prime of c is equal to 0. Here we have an example illustrating Rolle's theorem. So we have a function f of x is equal to x to the power of 6 minus 3x to the power of 4. Now we are told to find all values of c in the interval -2, 2 such that f prime of c is equal to 0. And note that the interval that we're given is open. So first of all, the function satisfies the conditions of Rolle's theorem. So f of a is equal to f of b. So if we plug in -2 in our function, f of -2 is equal to 16. And if we plug in 2, f of +2 is also equal to 16. Also, the function is continuous on the closed interval -2 and 2. And it is also differentiable on the open interval -2, 2. So the first step in finding all the values of c would be to differentiate. So using the exponent rule, f prime of x is equal to 6 times x to the power of 5 minus 12x cubed. Next, we will set the derivative equal to 0, so we can factor out a 6x cubed. So we are left with 6x cubed times x squared minus 2, and set that equal to 0. So that means the x values for which f prime of x is equal to 0 occur at x is equal to 0, x is equal to the square root of 2, and x is equal to the negative square root of 2. Rolle's theorem can also be used to prove the mean value theorem. The mean value theorem states that if f is a continuous function on the closed interval ab and differentiable on the open interval ab, then there exists a number c in the open interval ab such that f prime of c is equal to f of b minus f of a divided by b minus a. Here we're given an example where we'll be using the mean value theorem. So we're given two automated toll booths that are located 6 miles apart on a highway. So a car will pass the first toll booth and its speed will be clocked at exactly 60 miles per hour. 5 minutes later, it will cross the second toll booth and its speed is clocked at 58 miles per hour. So we're told to prove that the car must have exceeded the speed limit of 65 miles per hour at some time during the 5 minutes. So we'll let t equal to 0 be the time in hours when the car passed the first toll booth. Now when the car passed the second toll booth, that'll be 5 divided by 60, or 1/12 of an hour, because it took it 5 minutes to pass the second one. Now for our position function, s of 0 is going to be equal to 0 for the first toll booth. Now since there's 6 miles between the two, then s of 1/12 will be equal to 6 for 6 miles. Then, assuming that the position function of the car is differentiable, we can use the mean value theorem to find the average speed of the car over the 6-mile stretch of the highway. So we'll do s of 1/12 minus s of 0 divided by 1/12 minus 0. That'll give us 72 miles per hour, and therefore the car exceeded the speed limit of 65 miles per hour.